All right. Hi, everyone. Thanks so much for joining, taking time out of your busy schedule to join this talk. Really excited for this. What I'll be talking about today is building AI products to power growth. So really what I'm hoping that you'll get out of this is one, understanding how growth teams and growth products are created, and specifically within that, how AI products can help power growth. All right, so let's just start a little bit with an introduction here. So my name's Andrew. I currently work at LinkedIn on the growth team. I am working on specifically the My Network team. So what we do is we help members connect to the right network, connect to the right people. But my journey to get there, just a little bit of background, is I actually started off as a philosophy, political science major and moved into tech by way of some nonprofits, and then ended up working at an ad tech company in some client-facing roles. Then moved into engineering, working at a sales software company, doing hybrid engineering and PM work there. And then from there, I went into an ed tech company where I worked on creating a product that helped help people learn better. From there, I joined LinkedIn, where I'm at right now. I've been there for about 2 years. And on the side, some of my hobbies are music, traveling, all that good stuff. Cool. So then what do I specifically work on at LinkedIn? As I mentioned, on the growth team, I'm on the My Network team, and specifically what that is the actual product. So if you go onto LinkedIn, you can go to the tab and actually see the product that I work on. And the goal is to help members connect to the right people and build the right network so that they can be productive and successful. So specifically, that's connecting with other members, but that also means following the right things, whether that be pages, following hashtags, following other people, getting the latest and greatest from them. So yeah, that's the scope of the work that I'm on. Cool, so let's go through the agenda today, what we'll be covering. So the first section is going to be focused on talking about what is a growth PM. We can only really start this conversation if we have some working definitions here. And I've actually given a separate talk on specifically what makes a good growth PM, because that's something that we can talk about at length. But specifically, given that we're talking about how to drive growth through AI products, we'll be just spending a shorter amount of time there, specifically covering the 3 key points that I believe makes a good growth PM. And then from there, we'll talk about what is an ML/AI product? Really, what is the difference between ML and AI? When to use machine learning in product, and then how to create an AI product using machine learning techniques and algorithms. Again, this is also a field and talk that could be hours long in itself. So we'll be spending as much time as we need there for the context of this talk. There's actually a really good product school talk that covers this topic, which I reference in this section. So definitely check that out when you have some time. And then we're going to jump into the meat of it. So how do we actually use machine learning for product growth? How do we create these AI products using machine learning to drive product growth? So in order to illustrate some of these points, I'll be walking through 3 case studies. First one is people you may know, which may be a feature you may know already, someone who uses LinkedIn. The second case is improving follows for engagement. And the third is a ranking case study. Great. Let's jump right into it. All right, so what is a growth PM? So there's several ways to define what a growth PM is. It's traditionally something that's come from a broader growth team. So the way that this is a quote that I really like. So it says, growth product managers reduce barriers to value. So the focus here is really about driving value. And it's really about optimizing flows and products that have not yet been optimized for growth. So what does that mean? If there is a certain value that a product is looking to drive for its members, that can be measurable, that can be measured in a metrics-driven way. How the problem that a growth PM is trying to solve is how do we get that value to the member more quickly? And the how is also something that is very unique to growth product management, which I'll get into in a second. But this diagram on the right shows that there's actually a lot of different roles on a growth team. Traditionally, you have growth engineers, growth marketers, and specifically the growth PM is one that works in the product management function on this team. So as we continue here, some frameworks to cover before diving in a little bit more is whenever we talk about growth for a product or growth for a company, we have to talk about metrics. That's just necessary. And traditionally, when you think of growth metrics, you think of this growth funnel, aka pirate metrics, because they spell out R like a pirate. And so those are your acquisition metrics, your activation metrics, retention, and then if applicable in a B2B type context, revenue and referrals. So just to give some examples, acquisition is, hey, how do we get people to start using our product, right? So some examples of this may be invitation, referral type of acquisition product. So if you're using Uber, it's, hey, send another invite to a friend to get them to start using this product, right? Activation is once they're in the product, how do you actually get them to start using it? So let's say you sign up for Facebook, X many number of friends leads you to be an activated member, someone who's actually getting value from the product. Retention is once you're starting using it, how do we keep the user on board? Revenue is how do we generate revenue from those users, and referrals continues that cycle. So that's traditionally how growth metrics have been defined. One of the newer ways, which is actually more along the lines of how products nowadays work, are in this model, which is a loop model. So it's less about driving people and users down into a certain funnel, but it's more about how do we answering the question, how does your product grow? And so a lot of the times that question isn't answerable by just a strict funnel, and it's more in a loop type of model. So this is an image from Reforge, which is a fantastic growth-focused program. They have great resources, great blog, so definitely check them out. But this is an example they give with Pinterest, where you start with a new user, they get activated with some content, they pin some content, that content that then gets indexed on search indexes like Google, and then new members actually find those pins by searching on Google without even necessarily looking for Pinterest in the first place. So it's more of a loop model in that context. So this is just a framework to keep in mind as we talk about growth PM. So then, given that we have this definition for what a growth team is, what a growth product manager does, let's start thinking about what makes a good growth PM. So the way that I like to think about it, the way that my team at LinkedIn likes to think about it, is there's 3 core categories to really define what makes a good growth product manager. The first is that you are an ecosystem thinker. So specifically what this means is knowing your why and where your team fits into the whole ecosystem. The reason why that's important is because as a product manager on a growth team, you're focused on driving value as effectively as possible. And you can only really do that if you understand where the levers are in the ecosystem. So if you look here to the right, this is a diagram of the LinkedIn ecosystem where we have all our different products, the hiring platform, our marketing platform, our learning platform. It's based on the foundation of even having a professional network and a professional ecosystem of members who are all contributing and connecting to each other. And so this is really important as a growth product manager when you start thinking, hey, how to drive the value for, let's say, the campaign manager? How do I drive value for the hiring platform? It really helps to have an ecosystem mindset. So the second key factor in what makes a good growth PM is you have to be data-driven. And specifically, this is to make the right decisions. So data should back up all your decisions, all your hypotheses. You should never really be making decisions or having any hypotheses based on hunches. That's just poor form. So being a good growth PM means being a data-driven decision maker. And so finally, being a good growth PM means you're an experiment-driven learner, which means that you're acutely aware of what do you want to learn? What is the problem that you're trying to solve, and what's the biggest assumption that you have around that problem? So here on the right, we have a diagram of known, unknown known unknowns. And so if you look at this quadrant, on the top right, you have known knowns, things that you definitely know. So for example, by reducing the onboarding flow by 2 steps, we can drive the retention rate by X%. That might be something that you already know through an experiment. And then you have things that you don't know, but you don't know them, so you want to learn about them. So the way that you solve for those and find out those learnings is through experimentation. So to summarize, what makes a good growth PM? Ecosystem thinker, data-driven, experiment-driven in order to learn things that you just don't know yet. All right, so now that we've set some foundations on what we mean by growth product management, at least in this context, let's talk about, let's really shift gears here and talk about what is a machine learning AI product, and then we can start talking about how they fit in together. Cool, so again, this in itself can be its own presentation, but just to put it straightforward, at least for today, the way that we define AI is human intelligence exhibited by machines. Very vague, right? So I think one of my favorite examples of how vague this is that it changes a lot. So I think in the past, when people were devising chess algorithms, they thought that, hey, if a computer can beat a human in chess, that's human intelligence. And then once it happened, it was like, well, actually, no, that's still computer intelligence. We just got it wrong in the beginning. And then another example of that was then Go, which is that other board game, which has traditionally always been described as a type of game that requires human expression and like creativity in a way that machines couldn't emulate. And then, of course, recently, I think it was like 2 years ago, Google's AlphaGo came out, beat the #1 Go player, and then I think they created another Go algorithm that could beat that computer 100 to 1 or something. And then, so I think the point is here that AI, the definition of AI is, it is that human intelligence exhibited by machines, but it's very up to interpretation. So that leads to the second definition here, machine learning, which is a lot more defined. So machine learning is actually, they're techniques and algorithms that use statistics to find patterns in large amounts of data. And generally being able to pattern recognition, and then predict things based on patterns is what humans do. And so if you can employ machine learning, you can generally do what a human can do, at least up to the level that we have now. And then data science is the scientific method to extract knowledge and insights from data that can be fed into machine learning algorithms. So these are just some definitions. Let's move on before, so that we can illustrate some of the other points on how it fits into product. The question becomes, when do we even use machine learning? There's another image I actually was considering putting in here is the Gartner hype cycle. Machine learning and AI is a very hot topic that's thrown around a lot, and oftentimes is used in ways that shouldn't be used. So, let's really talk about when you should use machine learning. It shouldn't be for everything. This is one of my favorite quotes as well. If all you have is a hammer, everything looks like a nail. Basically, any problem that you're trying to solve is usually biased by the types of instruments that you have and the methods that you have to solve those problems. So let's dig a little deeper into what kind of problems are best suited for machine learning products. All right, so I'm going to talk about 6 types of machine learning problems here. These are not exhaustive, and each of these in itself can be broken out into other types of problems too. But for the sake of today, these are the 6 most common products and problems that you'll probably see in your day-to-day. So let's talk about number 1, ranking. What's the problem that we're trying to solve for here? So usually it's around helping users find the right thing. You can only really find the right thing if you've ranked the things first, right? So if you're looking for something very, very obvious example is Google search. You need to rank the things first and then have a way to show the highest rank result in order to help a user find the right thing. Another example might be feed ranking. So for each of these, I've tried to put in a LinkedIn case study case as well. So LinkedIn feed is optimized to help members see the best posts based on the people that they're connected to, the things that they're connected to. And so the problem that they're trying to solve is providing the best quality post, most relevant post through ranking. The second algorithm, a machine learning algorithm, is recommendations. So the problem we're trying to solve for there is how do we give users things that they may be interested in? The key operative word here is may be interested in. So already we start to see that there's never going to be a precise answer. There's never going to be 100% accuracy, but it's more around providing things that you may be interested in, people that you may know. So here, for example, we have our LinkedIn PYMK, which stands for people you may know. That's a product that I work on. So it's how do we show people that you may know so that you can connect to them. So that's recommendations. Other examples might be if you're a Spotify user, you're just the playlist that's generated to give you the best possible songs that you may listen to. All really interesting problems. All right, so number 3, regression. All right, so for regression, what we're trying to do here is the output of the regression algorithm is predicting an actual value of something for users. So one example could be salary prediction. Let's say I'm job seeking. I'm very interested in the location of the job. I'm interested in the benefits. I'm also very interested in salary. And salary is like a hard number, right? It's not this ambiguous value. And so a regression algorithm is used to provide that kind of prediction. It's a prediction based on other inputs and other data. So whether that be market information or previous historical data, the output is this actual value. So that's what a regression algorithm does. And then our fourth is classification. Help users understand what kind of thing is this, right? Putting it into buckets of things. So the example that we have here is being able to identify invitation spam. So if you have a bunch of invitations being sent to you, a lot of them are not going to be relevant. How we define that is also something that needs to be done. But being able to classify this as spam, this is not spam, this is something I might be interested in, might not be interested in, is classification. You'll also start to see that some of these overlap a little bit. So you might have a ranking algorithm that's based on recommendations. So it's also something to note. All right, so then getting to the last 2 here, we have clustering. So that's putting things together in similar fashion based on putting similar things together for users to help them derive value, whatever that may be. So for example, on Amazon, people also bought is a grouping. The value that we're trying to drive there is people also bought this. So the value here may be that this is something you're interested in to purchase. Another example is group to recommendations on the PYMK front. So that's a case I'm actually going to go into in a second. So it's like, hey, here are people you may know based on a school that you attended. Or here are people that you know based on your role. You're a product manager, here are other product managers. So that's what clustering is. And then finally, we have anomaly detection. This is just finding uncommon things. So a really interesting example is actually trending products. So when something's trending, it means that it's differentiated a little bit, right? So if you look at Twitter and there's a trending topic, it's that, hey, people are talking more about Michael Jordan right now for some reason because that documentary is out right now. And so normally people are not talking about Michael Jordan. It's been a while since he played, but there's an anomaly. There's something strange because more people talking about Michael Jordan than they normally would. So calling that out would be identifying that it's a topic now. So yeah, these are the types of problems that machine learning can solve. Just going back to that previous slide, if you are if you're thinking about when to use machine learning in product, it should be really around a certain problem that you're trying to solve for. And generally those problems that you're trying to solve for should fit into one of these categories. There's also tons of other caveats, but generally speaking, that's how you should formulate your problem. All right, so in addition to talking about what kind of problems that we're trying to solve for, it's really important to think about the actual machine learning product lifecycle, because not only does the type of problem that you're trying to solve for, should that be the consideration for when you should use machine learning, but understanding what is even required to develop a machine learning product, that should also drive your decisions. So specifically what I mean is the following. So this diagram is from a fantastic talk given by a Google PM through product school as well. Highly encourage that you look it up. I found that it's actually referenced in a lot of different blog posts too, because it's so well put together. So just Google, good ML PM product school talk. But the machine learning lifecycle is as follows. So you have your problem statement, as we mentioned before. The actual algorithm and product that you develop is highly dependent on the data that you have. So given that machine learning algorithms learn based on their inputs, and the inputs are data, you have to have the right data to begin with in order to even begin developing a machine learning product. So going through this flow here, you formulate your problem, you select and pre-process the data that you have, which is, it's a tremendous amount of data that you have to go through. So in itself, you have to label the data for it to be usable. If it's unstructured data, you have to be able to put it in a structured format that works for your team. So that in itself is the whole process. And then step 3 is feature engineering. So given the problem and the objective function of the algorithm, how do we then decide what features to consider in the algorithm? So for example, people you may know algorithm, some features in the feature engineering set would be school that you attended together, mutual connections, the industry that you're in. These are all part of the feature engineering process. And then for each of those, you have to decide how to weight them. The weighting should technically be done based on the data you're getting. And so in itself is a whole process. And then step number 4 is training, testing, and continuing to tune the models. So not only once you've ramped the model to begin with, do you need this whole process, but as you continue to tune the models, as you continue to update the models in real time, you need to be super certain that that's something that your team can even support before pursuing a machine learning product. So, all right, when should you use it, right? When should you even use a machine learning product? When you're dealing with complex logic that ideally cannot be resolved with just if-else statements in business logic. And usually that's because you need it to be number 2, personalized. So complex logic is necessary when you want your recommendations or your ranking to be personalized to each individual user. If you had to do that through business logic, that would just be a nightmare to have enough cases and enough functions to deal with that. So definitely use a machine learning product when you want it to be personalized. And the third is actually probably one of the most key, which is you want it to be in real time. So adapting in real time. Using the people you may know example again, your mutual connections change all the time. People go to different schools all the time. They switch industries all the time, right? They're changing jobs all the time. So if you want your product to be personalized in a real-time way, definitely use a machine learning product. All right, so when should you not use it? When you can solve your problem using business logic. And then as I mentioned in the whole product lifecycle, ML lifecycle, if you don't have enough data to begin with to even train the model, then you're going to have a number of issues. One is that you might just push through and actually create the model, but it's going to be a terrible model. It's going to be extremely biased. It's going to be biased towards the small amount of data that you have and the low quality data that you have. There's tons of examples of products out there that used bad, it's hard to say if it's bad, but at least biased data, and created a really bad experience for people. I think one example is that Tay bot is like a Microsoft Twitter bot that consumed a lot of the vitriol and bad tweets and ended up becoming this like very evil Twitter bot. So yeah, definitely use machine learning if you want to solve for a personalizable real-time problem. Don't use it if you can just use a hammer, using the analogy from before. All right, so up to this point, we've talked about what a growth product manager does. A growth product manager is looking to drive value as effectively as possible for the users, looking for optimization opportunities in the entire ecosystem. Machine learning products are used to solve for complex, personalized, real-time problems. And often those two can work separately, like you're using business logic to do growth type of problems. You're using machine learning for non-growth related problems, but let's start combining them. When can you use machine learning for growth? And let's use some case studies to actually illustrate these points. I think one of the most exciting things about this combination is, well, one is that a lot of really interesting inventions or interesting advancements in history have been from combining two things that initially might have seemed different into something that is something definitely new, right? So a very non-tech related example is actually the printing press, a very classic example. Printing press was, I think Gutenberg took a wine press, so like the actual presses that were used to turn grapes into wine. And then there was already the lettering system, which was like very manually putting together letters and then like, typing out documents. And he just took those two and then combined them into this machine that could just press type very quickly. That led to the mass production of text, which led to the mass dissemination of text, which led to knowledge, right? So it's very cool whenever you have these two different inventions that get combined into something that's very special. So personally, I feel that that's where we're going when it comes to growth, product management, or just growth in general, and then using machine learning products to drive growth. So let's go back to the original criteria that we're talking about on what makes a good growth PM. So being an ecosystem thinker, data-driven decision maker, experiment-driven learner, how do we use machine learning based on what we know so far to meet these criteria? So with the ecosystem thinker, asking oneself, how does machine learning play into this overall ecosystem? Like, where are all the levers? Where are all the inputs and outputs? And which of these places are ripe for using machine learning? The answer is often no. Like, the answer is often, let's not complicate it. Let's just use a traditional feature. But a lot of times it's perfect for machine learning, as we'll talk about in a second. All right, and then for second point, since data needs to back up all your decisions and hypotheses, where can we use machine learning to get as much data as possible, get all the right data that we need to back up decisions and drive hypotheses? And then finally, as we talked about, you're asking yourself, what do I want to learn? What's the big assumption that I have? How can we use models? How can we use machine learning to find those learnings, to find those insights that will then drive learnings? Great. So then I want to go through 3 case studies that illustrate this, I don't like the word, but synergy, this combination to illustrate this point. All right. So case 1, people you may know as grouped recommendations. So as I've talked about a lot in the previous slides, we have this product called People You May Know, which the goal is to show you people you may know. Very straightforward, right? So one hypothesis that we had on the My Network team is, okay, that's great, But what if we showed them in grouped recommendations? So the hypothesis here is if we show groupings of recommendations, our members will have better recommendations, have more crisp insights into people they may know, and that would lead to connecting more, right? So the hypothesis is very much around how do we leverage this, our clustering grouping mixed with recommendation in order to provide the best recommendation. So if you see here, we've listed the hypothesis. We've also listed the ML that is leveraged in order to test this hypothesis. And then, as we discussed in the previous slide, being very data-driven and experiment-focused in order to get those learnings is important as a growth product manager. So let's walk through this. So the metrics that we'd be measuring is member-to-member connections, right? So that's how we would know, that's our learning. Our experiment is that if we do the groupings versus non-groupings, so the groupings would be one variant, and non-grouping would be the control. In fact, within the groupings themselves, there's multiple variants. You could do groupings based on these different features, but you can also do groupings based on weight. So do we lessen the bar for what counts as a grouping? Do we be really strict about the quality? Like, there's all sorts of different variations you could do within the model itself that lends itself to driving these kinds of experiments. And then the ecosystem thinking throughout all of this is that as we increase quality connections made, it's better for the LinkedIn ecosystem. You don't want an ecosystem of professionals based on very loose connections. You want it to be based on very strong connections, these clustered type of connections, for future benefits, right? So if you want to reach out for a referral, you want to stay in touch, stay informed, things like that, really good for the ecosystem. So just going back to our previous slide here, ecosystem thinker, data-driven decision-making, and experiment-driven learner. We really hit all those three criteria with this experiment, and this experiment leverages machine learning, given that the recommendations are going to change depending on what people went to. There's people always graduating, there's always going to be different things that have to be updated in real time. All right, let's jump into case 2. This one is improving follows, follow recommendations, for engagement. So the hypothesis here is that if we improve the recommendations that we show you for following, that will optimize the engagement. So just even the following rate, and that in itself will lead to more engagement on the content that comes from those follows. So just backing up a second, the mechanism that we're dealing with here is like, let's say we see this Steve Norrie here, the first recommendation. If I follow him, then I'll start seeing content from him because he's a data science leader and I'm very interested in data science. I'll see his content in my feed, right? And so if I see his content on my feed, if I get notifications from him, I can engage with that content, like, comment, share, all those things. And that in itself is a virtuous cycle of, it's good for the ecosystem, right? So if I follow different people and I see their content and engage with it, that's great. It means we have an active community on LinkedIn. But on the flip side, if I follow someone and I see their content, it's not good, it's not relevant at all, even though I did follow them, then that leads to a bad experience because then now I lose a little bit of trust in the recommendations that are even being shown to me. As a member, I say, hey, why was that even being shown to me in the first place? I see their content and it's like, this is not interesting at all. I unfollow even, right? So the hypothesis here is that if we improve these recommendations, and what we mean by improvement specifically is that the recommendations are being shown will optimize for engagement, then it'll lead to more content engagement. All right. So what is the machine learning algorithm here that we're utilizing? So this is actually more of a tuning. So improving the existing recommendation model to do what we've listed above, which is optimizing for engagement. Very broad, right? But more precisely, what that might mean is making the prediction response of the recommendation algorithm optimized more for the actual engagement actions that a member has on the content that comes from that individual recommendation. So I think a clearer way to put that is that you could optimize for something like optimizing for clicking on the follow button, right? That's not what this algorithm does. This algorithm optimizes for that you would click on the content that comes from this recommendation. So this is more of a tuning. And then as I mentioned, the ecosystem here, ecosystem thinking here is that if we improve the quality of the content, if we improve the interaction rate on the content that comes from the recommendations, that's just good for the entire ecosystem as a whole. Because now we have members coming back to the platform, trusting the platform for quality content, trusting the platform for good recommendations, just leads to more community forming, more activity on the platform, which in turn helps out those other parts of LinkedIn, whether it be marketing, sales, etc. So just overall very good. And then being very data-driven, what are the actual exact metrics that we're going to be measuring? Downstream interaction. So we have actual metrics around like, comment, and sharing. And so this is another case for how we might use machine learning in order to drive growth and then help out the entire ecosystem. All right, so case 3 here is ranking the recommendations. We talked a lot about improving the recommendations being shown, improving and optimizing the downstream impact of recommendations being shown. But this case study is specifically around ranking the recommendations once you even have them, right? So on the My Network page, if you go there right now, you would see recommendations for different hashtags, groups, people you may know, which is great. But how do we actually rank those recommendations, right? So our goal here is to provide the best recommendations at the top, similar to like a Google. If you search for results, the goal and the problem we're trying to solve for is making sure that the best recommendations are shown at the top, that search results are at the top. Similarly, we want to show you the best recommendations and the best grouping of recommendations at the top. So our hypothesis here is if we rank recommendations based on the likelihood of the member engaging, we call that p-click, the probability that you'd click on those, then members will connect more and follow to more things that they care about, which, as we showed in the previous case, that leads to a better ecosystem and so on. So the machine learning algorithm that we're leveraging here is a ranking algorithm. We are ranking based on the probability that you'd click on these things. And then how it helps out the overall ecosystem is more quality edges. We call an edge your connection to any of these things. So an edge might be I'm following something. That's one edge. Another edge might be I'm connected to someone. It's another edge. Another edge might be I just joined a group. So the more edges that we have, the more quality edges that we have, it leads to a richer overall ecosystem on LinkedIn. And the metrics that we're going to be measuring are what we call active edges, or let's just say they're quality edges here. As I mentioned, connections, follows, joins, even subscriptions, all those are considered edges. So the better, more high quality active edges that we can drive through this ranking experiment, the more that we would actually, we'd help out the overall ecosystem. So yeah, so for case 3, a good example of where growth in machine learning merges is through ranking. So that was a lot. I hope that you all have, I hope that through the case study specifically, we've been able to illustrate here how machine learning can build AI products, but specifically can drive growth. As I mentioned, I think this field is very ripe for exciting developments. I wouldn't say innovations per se. I just think it's that you can just mix and match a lot of different things. So just some key takeaways here. Just to start is what makes a good growth PM, right? So even aside from machine learning, aside from all that stuff, if you just wanted to focus on growth product management, a good growth PM is one that is an ecosystem thinker, one that is data-driven to make decisions and also form hypotheses in the first place. And then third is very experiment-driven for learnings to test hypotheses and to validate assumptions or invalidate assumptions. So that's what makes a good growth PM. And then ML AI products are not one size fits all. Really, the questions that you have to ask yourself here are, what is the problem that you're trying to solve in the first place? It's key because a lot of the times, as we saw on that table, there's some that are so well suited for machine learning and some that are just not at all. It'll actually save you time as a product manager. It'll save your team a lot of time. Your engineering team, your infra team, all those teams will love you for that. So being really crisp and clear about what the problem is that you've been trying to solve. The second actually ties in really well to number one, which is like, does it have to be personalized? And number three also is like, does it have to be adaptable at scale? Does it need to be in real time updating the kinds of, basically does the product itself need to be updating and learning on its own in order to solve the problem that you stated in number one? Cool, so that's number two. Second section. And then in terms of combining growth and machine learning, it's really about how can I improve, asking yourself, how can I improve the overall ecosystem using machine learning and what I know about the types of problems that machine learning are best suited to solve. What data do I even need to make product decisions, and how will machine learning get me that data? And then finally, what are my biggest assumptions and what kinds of ML model iteration experiments can help me learn to get those learnings, which then in turn can help inform your future experiments, make a better product, drive the most value for your users. So yeah, for me at least, this is how you create machine learning products to drive growth. Hopefully, my hope is that if I do this talk again in 2 years' time, there's gonna be a lot more exciting stuff to talk about, a lot more new case studies and examples. So I'm really looking forward to that, and hope you all got something out of this presentation. Thanks.